Okay, so what we're going to do here is we're going to go through the Chapter 13 test review. I'm only going to go through the first copy of it. There are on here 3 versions. Here's the first version. You see it says ID2. This is the answers to it. And then if we get down here enough, we get ID4. Again, there's the problems, and then following that, there are the answers for ID4. And then there's ID5. So you've got 2, 4, and 5. And I'm going to go through number 2 with you and just try to show you exactly how you'd answer all the questions, why these answers pop up the way that they do. Rather than just giving you the answers, I want to make sure you understand how we're doing it. And then I would encourage you to do the other 2 versions by trying to see if can you get the correct answers for each of them. And so we're going to be kind of going back and forth with some of the draw options. Hopefully my handwriting won't be too terrible on here. But we're going to start with number 1. It's a tangent of theta. And you should be able to do the sine, the cosine, and the tangent for any of these without any too much headache. From theta's perspective right here, okay, the 15 becomes the opposite side. Of course, this 25 being the diagonal away from the right angle is our hypotenuse, and the adjacent would then be our 20. So the tangent of our theta in this problem would be the opposite, which is 15, over the adjacent 20. Yeah, I do expect you to remember that the sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, when they reduce, you should reduce. These both divide by 5, producing 3 over 4. Question number 2 says, what's the tangent of theta? Well, here, you know what? I'm going to give the tangent, but I'll also give the sine. Remember, the sine is opposite over hypotenuse, so we'll do that along the way. But here from theta, the opposite would be my 12, the adjacent would be my 9, and the hypotenuse, of course, is this longest side, 15. So for the tangent of theta, the answer to the actual question, it would be the opposite, 12, over the adjacent, 9. Again, these reduce by 3, producing 4 over 3, which is great. That's our answer. But I want to make sure that we're clear on how to do. That is a terrible. Start that over. 4 over 3. There you go. I want to make sure we also understand how to do the sine, which would be the opposite, 12, over the hypotenuse, 15. Again, these do divide by 3, producing 4 over 5. Okay, so if you were asked to do the sine, that's how you would do the sine slightly differently. Here we have the cosine, which is the adjacent over the hypotenuse. Here's our opposite side at 8. Our hypotenuse, of course, is 17, and our adjacent would be 15. So the cosine of theta would be the adjacent, 15, over the hypotenuse, 17, and since that doesn't reduce, we're done. The next question, number 4, says solve the right triangle. Well, to solve a right triangle means to find all the sides and all the angles. Now, this is a right triangle, so this is one of the easiest ones we can come up with. But we are going to have to use some trigonometry to do it. So first, let's list what we do know. A is 32 degrees, B is unstated, and C from our diagram is 90 degrees. Before I go any further, I can figure out that angle B has to be 58 degrees because I have to get a total of 180 degrees. Please be careful with that. Make sure that it actually adds up to 180. I get a lot of people who right here would put like 68 because the 30 and the 60 make 90, but because you've got the 2 and the 8, you have to cut 10 off. So be careful about stuff like that. Little a, we don't know. Little b, we don't know. But little c is 6. Now 6, that is our hypotenuse. Okay. Little a over here is the opposite side, and little b is the adjacent side. So to find the adjacent or the opposite, we're going to use a trigonometric ratio. So let's go ahead and let's use, because I've got the hypotenuse, let's go ahead and use sine. That would give me the opposite. Sine of 32 equals the opposite, little a, over the hypotenuse, 6. To solve this, I had times by 6. and I get little a equals sine of 32 times 6. Well, I'm going to use my calculator for that. We'll go in and do Desmos. And, let's shrink this down just a little bit. Here we go. We'll do this as 6 times, and our functions right here, sine of 32. You will need to use Desmos or a personal calculator. And so do make sure that you're in degree mode, which we are here. We get 3.2. Over here, we're going to put, for little a, 3.2. And then for little b, we can use Pythagorean theorem because we have a right triangle, but I'm a way more consistent fan of doing another trig ratio. The cosine is adjacent over hypotenuse. So the cosine of 32 would equal the adjacent little b over the hypotenuse 6, which again we times by 6. And so I can come back to Desmos and change this to a cosine. Back, and just clear that sign. And I get 5.1. Okay, so I can come in and say this is 5.1. And there we found all three sides, all three angles. We're pretty happy with that. We can move forward. The next two are about converting from radians to degrees and degrees to radians. The reality is we're always timesing by 180 and pi, but we're creating a fraction out of them. If pi is in the problem, we're going to put pi on bottom. The goal is to actually cancel them. So we have 180 over pi. The pi's are going to cancel, and we need 4/3 times 180. You can reduce this by hand, or feel free to put it in the calculator. In the calculator, it would just be 4 divided by 3 times 180. And that gives me 240 degrees. So this becomes 240 degrees. This is the exact opposite. We're going to times by pi over 180. I don't actually want to multiply by pi. What I want to do is take 210 on top of 180 with my pi and see if 210 and 180 reduce. Looking at them, I know they both divide by 3 or by 30, right? The zeros can cancel, and then 21 and 18 divide by 3, giving me 7 pi over 6. If you struggle with that reduction, just show your, this might be a case where you're going to show some work. Do the best you can. If you put in 210 pi over 180, you can still get a good amount of credit for that. So just be careful. Try to reduce them. They're not crazy hard to reduce, but I'm asking that you make that effort. Well, we're about halfway done now. 7, 8, 9 are about finding a missing angle. Now, each of them is set up or could be set up for different information. It looks like these three have all actually been set up for the same thing, which I'm not a huge fan of. So, I'm going to show you how this is done, but I kind of don't like the questions. They all look like they've been set up as tangents. This is the opposite side and adjacent. Again, opposite, adjacent. Let me make this very clear. They are not all going to be opposite adjacent problems on the test. You're going to have an opposite hypotenuse, an adjacent hypotenuse, and an opposite adjacent. Basically, you're going to have a sine, a cosine, and a tangent on this. When the test generator created the different versions, apparently they ran out of ideas. So these are all basically the same, but the point is to figure out which trig ratio uses these two sides from your angle's perspective. And again, all three of these are going to be tangent because opposite adjacent is tangent. So you'd start by saying the tangent of your unknown angle is the opposite 24 over the adjacent. Oh, that's a hypotenuse. Geez, Mr. Welch. Hold on. That's a hypotenuse. That makes me feel better. So let's start. Ooh, we got to clean this up. How many other ones did I screw up on? Let's find out. Well, that's not right. That's a hypotenuse too. And that's it. Man, Mr. Welch, looks like the one thing you didn't get in here was a tangent. Gosh. Start over. That's an opposite and that's a hypotenuse. Man, that's opposite and that's a hypotenuse. That's opposite and that's a hypotenuse. Man, now we've got only sines. Okay, so now they're all sines, but the point is, whichever ones you're given, you use that trig ratio. So sine of my unknown is the opposite, 24 over 38. And to solve for theta, we have to remove the sine function. To do that, we use a sine inverse. And what we do to one side, we got to do the other. So I'm going to grab my calculator real quick, and I'm going to choose the function sine inverse. If it was a cosine, I'd use cosine inverse. A tangent, I use tangent inverse. This is how we find angles. Not sides, angles. And so we're going to put the 24 divided by 38, and we get 39.2. This first one would be 39.2 degrees. Over here, our sine of theta would equal the opposite, 4 over the hypotenuse, 12. Again, we take a sine inverse in order to figure out the angle. So, you know what, let's just come back here, backspace, 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 backspace. It was 4 over 12, comes out to 19.5. So here theta equals 19.5 degrees. And then our last one, opposite, is 23. So sine theta would equal 23 over 38. And again, we take the sine inverse. I can't stress enough, guys, it's not going to all be sines or cosines or tangents. You're going to have a mix. So I feel a little bit bad about that, but I do want you to see why we're getting the answers we're getting. So right here, we're going to put 23 divided by 38, and we get 37.2. All right, so those are our three answers. I wish they were different each time, but they are what they are. Now 10 and 11, they're going to be asking again, solve the whole triangle. So on number 10, you can imagine I've got to have A equals, B equals, and C equals. And I got to get little a, little b, and little c. Now, capital A is not listed. Capital B is 90. Okay, I'm going to tell you right now, do not expect a 90-degree angle. It's not going to happen. My bad that it exists in it at all. It's not on the test. And then little big C is 59 degrees. To find the missing angle, we're going to add from 180, or add up to 180. So that gives me, 31 degrees. Again, don't expect a 90. So I'm going to treat this as if I didn't have a 90-degree angle, because you're not going to on 10 and 11. And then we're working off of the opposite side. So little a would be opposite of big A. That's 18. And I don't know B or C. But because I have big A and little a, I can use the law of sines. Now you're going to be given the law of sines, or told that you need to write the law of sines down on a sheet of paper that you're allowed to have out. Please don't fill it up with a bunch of other nonsense like this answer key. I'm just asking you to be honest. Own your mistakes, own your lack of understanding. Ask me for help. Put in the time ahead of time, and you'll be all right. Okay. But because I have both A and A, I can use that information with one of these others. I'm going to go ahead and do it with B and then eventually with C. I'm going to start with B over the sine of 90 equals little a, 18 over the sine of 31. To get little b alone, I need to times by the denominator, sine of 90. But to do that, I have to times over here by the sine of 90. Obviously, you guys can be stopping this to slow it down and to ask questions along the way, or shoot a message into me. I've got 18 divided by the sine 31. And then I'm timesing by the sine of 90, which comes out to 34.95. So I'm just going to go 34.9. That was for B, 34.9. To find C, Yeah, on this one you could use Pythagorean's theorem, but I don't want to go down that road. Just trust me. Get used to doing law of sines. So here, to find little c, we're going to start with little c over the sine of 59 equals little a, 18 over the sine of 31. And again, we're going to have to times by the sine of 59 this time in order to get rid of that and be left with little c equals. We'll grab this right here and we're just going to change that 90 to a 59. And we get 29.95. That's going to force us to go to 30 even. So this would be 30.0. And there is our answer to the nearest tenth for all those. Okay, now I'm going to have to erase a little bit to make some room here. So kind of bear with me here while we make room. You know, you can back up and rewind, so I'm not too stressed about what you do and don't have in front of you the whole time. But, you know, the formulas are there. Time is here for you. Come and get the help you need. Don't wait till the last minute. This is all going to be done on Friday. So, you know, don't wait till Thursday to start studying. This should really be Monday and Tuesday, giving you lots of time to come in and ask questions so that you can get the help that you need when you need it. Okay? Just figure I'll clean the whole thing up while I'm at it. Take a little brain break for you, get your notes caught up. I could pause it and erase all this, but now I've gone so far down this rabbit hole, I feel trapped, like I really should spend the time and waste everybody's time. So you guys can fast forward till you see me writing again, or just hang out and breathe. I think we don't breathe enough, like the real breathing, meditative breathing, where you really just take it in and accept life for what it is. I mean, don't breathe near other people. Probably give them a virus. But anyway, all right, so now we have number 11. Same idea. I want to find capital A, which is 100, capital B, which is unknown, and capital C, which is unknown. I need little a, which I don't know. But I do know little b is 27. I know little c is 24. Whoop. Oh, hold on. Lost my room here a little bit. There we go. I know that little c is 24. Now, because I don't have both a's, both b's, or both c's, I'm left with the law of cosines. Now, you may or may not remember, but the law of cosines should look like this. A squared equals b squared plus c squared minus 2bc cosine of big A. Notice you're looking for little a, which is right here. So I can say that a squared equals little b 27 squared plus 24 squared minus 2 times 27 times 24 cosine of, not run out of room here, my angle is 100 degrees. This is really important. None of this is a variable, so it can go straight into the calculator. And that'll give me a squared equals, and we'll just grab our Desmos one more time on this set and do 27, and there's my squared, plus 24 squared, minus 2 times 27 times 24 times the function cosine of 100. Don't stop midway through your calculation here. We press enter, we get 1530. That is a huge number. So over here I'm going to write 1530 point ... Okay. Well, to solve it, I've got to take a square root of that to get a completely alone. So I go back into my calculator and I'm going to take the square root of 1530.05. Let's go out about that far. 39.1. So I'm pretty happy to just come in here to A and call it 39.1. Now that is bigger than these other two, which is good because 100 degrees is as big as any of the angles is going to be. It's my biggest angle by far. And so that's a good thing to have. Now I have both A's, which means I can use the law of sines. I can actually revert back to that method. So I'm going to grab maybe a different color here, and I'm going to set up for a law of sines. Let's go after after big C. So the sine of big C over 24 would equal the sine of big A 100 over little a, which is, we said 39.1. Okay. And now to solve for C, we're going to times by 24 on both sides. And we'll get that the sine of C equals some number. So let's go find out that number. Let's get rid of that one, and 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 that one. All right, here we go. We've got the sine of 100, close those parentheses, divided by 39.1, and we're going to come over, and we're going to times by 24 to get an answer of, whoops, get rid of that equal sign. Enter. 0.6045. 0.6045. But remember, that's not C. To get C, we've got to get rid of the sign. So we're going to invert the sign. The sine inverse on our number here. So we grab our calculator one more time. We're going to take the function sine inverse of this 0.6045. We'll round it somewhere along the way, and we get 37.2. So now I have that my big C is 37.2. And to find B, I'm just going to subtract from 180. Let's make sure that we got all our numbers right so far. 37.2. And if we take 180 minus 37.2 and minus 100, we get 42.8. And there is our solved triangle. All three sides, all three angles. All right, one more time we're going to erase, and then we've got one really easy question left that should be pretty straightforward. Now again, you are asked to write down the law of sines, the law of cosines, and this last formula called Heron's formula with the rule for the semi-perimeter. Now if you remember Heron's formula, good for you. You don't need to write everything down if you want to memorize it instead, but it is up to you, your choice, how you want to manage that. I'm asking for the area of this triangle. Now Heron's formula, you know, they use A, B, and C instead of P, Q, and R. So if that bothers you, you are more than welcome to come in here and relabel this A, B, and C. All that really matters is first you need the semi-perimeter, the S, which is half of the perimeter. So you can take 13 plus 15 plus 6, and you divide all that by 2. 13 plus 15 is 28. 28 plus 6 is 34. Half of 34 is 17. All right, then there's Heron's formula, which says the area is the square root of the halfway around the semi-perimeter times the semi-perimeter minus each side, minus 13 times 17 minus 15 times 17 minus 6. Now I could come in and I could figure out this is the square root of 17 times 4 times 2 times 11, or you can type the whole thing in all at the very beginning. It doesn't actually matter how you evaluate this. We're going to put the square root of 17 times 4 times 2 times 11. And we're going to get 36.7. Keep doing that. I meant to hit that. All right, 38.7. Now this does have a unit on it, so we really should say that the area is, when that happens, 38.7 yards squared. And there would be our final answer. Well, guys, that's what the test is going to look like. That's what you need to be able to do. I talked about those three formulas. I do ask that you memorize sine, cosine, tangent is opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. But otherwise, hopefully that's enough to get you through there and answer some questions. Come in and ask, practice on the other versions, and we'll see you when we see you.